Good evening. Today class is mass spectroscopy. Here, the mass spectrometry. We can study about the mass spectrometer equipment. We have to start it with the introduction, principle, instrumentation, types of mass spectrometers, and types of peaks we can observe in this mass spectroscopy, and also applications. What are the applications of mass spectrometry? Introduction. Mass are also called as molecular weight of a compound. Uh, what is the molecular weight of helium? What is the molecular weight of gold? What is the molecular weight of silver? Mention in the comments, and then let's get started. Introduction. Mass or molecular weight of a compound can be found in several ways. One such technique is using mass spectrometer. This is the mass spectrometer which is used to know the spectroscopy, and this is also used to determine the structure elucidation and quantitative analysis and some mass of the compounds, molecular compounds. And here the main principle is uh, it is mass spectra is also called as positive ion spectra or line spectra. And here we do not use any type of electromagnetic radiation for excitation, because here the excitation state or ground state are not be presented, they are absented. And here we can consider in two steps, like conversion of neutral molecule into charged molecule and separation of the positively charged fragments are passed based on their masses. As we know, if a school or if a company contains so many workers, so many students, the teacher divided the students by their marks or their knowledge, as well as in company also the manager or the employee. The manager can promote the workers like management, HR, and workers, co-workers, and team leaders according to their knowledge. Likewise, here also the separation of the charged particles or fragments can be formed by their positive charge or negative charge. And here we have to notice that in mass spectrum only positive charged molecules when we occur. The sample is bombarded with the high energy electrons. The electrons are knocked off from every molecule. Hence, the molecule becomes positively charged. When a positively charged molecule get repelled, when we already know this, if a positively charged magnet is there, it naturally repelled to the negatively charged magnet. Likewise, here also the molecules are positively charged, they get repelled and they travel with the great speed in a straight path. So, according to that, potential energy is equals to the kinetic energy of molecule. Here we see an equation like EV is equals to half mv square. Here where the charge of ion means it denoted as E, and acceleration voltage is denoted by the V, and mass denoted by the m. Velocity after acceleration can be denoted by the V. And when a magnetic field or electric field is applied to that positively charged fragments, it will be traveled in a straight line. And now we can observe a curved path because we applying external charge or external field like magnetic field or electric field. And when they travel in a curved path under the influence of magnetic magnetic field, the fragments are separated into different masses because the radius of curvature depends upon their respective masses. This is also natural because according to the mass, the charged particles will be separated when it will be in a curved. When we see a straight line or a naturally occurred straight line, there is no mass differentiation is observed. Hence, the magnetic field can be written as HEV is equals to mv square by r. Here r means radius, m means mass, and v means we already know velocity. The equation is finally comes here. H means strength of the magnetic field. Here V is equals to the REH by M, and we can substitute the V value in equation. In this equation, we can substitute the V value. What will be happen? EV is equals to half into M into REH by M square, and here the simplifying will occur. M by E is equals to H square R square by 2V, and M by E is directly proportional to the R square, hence H and V are maintained constant. Mass is directly proportional to the radius of ions, since the positive charge is become 1. And instrumentation, we already told that here the mass will be applied when it will be formed as a curve. We can see this. The diagram of single focusing or electron impact mass spectroscopy is there. Here comes sample inlet. We inlet the sample here, and the ion source will be formed, and then plates are accelerated, then vacuum will be applied to this tube, and the ion beam will be occurred, and the collector will be here. The amplifier and recorder, we can see the fluctuations, or we can observe the mass of the particles or molecules in it, and the horseshoe shaped glass tube which is evacuated, and sample inlet is there, electron bombarding source and accelerating plates on one end. At another end, collector slit is present, which is a note which is used to observe the readings, and it records everything what happens in the mass. And here we see that mass spectral pattern is like this. If the intensity increases, the mass will be increases, it will be changed because it is in a curve shape. And types, what are the types of mass spectrometers? Like electron impact mass spectrometer, chemical ionization mass spectrometer, field ionization mass spectrometer, field desorption technique, plasma desorption technique, laser mass spectrometer. These are the types of mass spectrometers. And types of peaks. What are the peaks types? Means parent peak, mass peak, molecular ion peak, and second one is base peak, third one is M plus 1 peak, and fourth one is M plus 2 peak. Here the peaks will be formed by their highest value and lowest value. We already know this curve. So the molecular arrangement, by the molecular arrangement the peaks will be occurred. And applications, this mass spectrometer is used in structure elucidation of the particles or any compounds like nitrogen and some other. Detection of impurities and quantitative analysis, this mass spectroscopy used in analysis also, and mass spectrometer also used in the drug metabolism studies and clinical toxicological forensic applications, like means it is used to find the mass of the compounds which present in a drug. These are the applications of the mass spectrometer. Thank you.